All right, so I moved around and showed you what that error looks like. So let's get in writing before you go. Alternating series remainder / error. If an alternating series satisfies the conditions of the alternating series test, we can approximate the sum of the series using an nth partial sum. If an alternating series satisfies the conditions of the alternating series test, we can approximate the sum of the series using an nth partial sum. We can also find the error associated with, you know what, go back here and in parentheses where I have the nth partial sum, put S sub n, so you know what I'm referring to here. We can also find the error associated with S sub n. It will have an absolute value no greater Sorry, I didn't write this sentence exactly right. I want to make sure that I'm saying what I mean to say.
It'll have an error no greater than.
It will have an absolute value no greater than the first term left off in the sum, i.e. a sub n plus 1. We can also find the error associated with S sub n. It will have an absolute value no greater than the first term left off in the sum, i.e. a sub n plus 1. So the error is the real sum minus the partial sum, and that's got to be less than or equal to a sub n plus 1, right? The next term. Let me see if I can get us through one example, okay? Approximate the sum of the convergent series n equals 1 to infinity of negative 1 to the n minus 1 over n factorial using the first 6 terms. Find the error associated with this sum. Approximate the sum of the convergent series from n equals 1 to infinity of negative 1 to the n minus 1 over n factorial using the first 6 terms. Find the error associated with this sum. Okay, so let's do my 6th partial sum. It starts at n equals 1. I have to pay attention to that. So what's the first term? 1, right? If I plug in a 1 right there, it's negative 1 to the 0, which is 1, over 1 factorial, which is 1, minus a half, plus 1/6, minus 1/24, plus 1/120th, this, yeah, it's abbreviated in. Okay, so those are my first 6 terms, right? And that is the decimal representation of that is 0.632. So that means that the series, right, is approximately equal to that. I wrote down both of those because I wanted you to see the difference here. I can say that S sub 6 equals that, but if I'm going to approximate the series, I need some approximate signs with that. And I swear I'm almost done. So the error is S minus S sub 6, right? And that's got to be less than or equal to what? A sub 7, right? So S minus 0.632 has to be less than or equal to that right there. 1 over 5,040. So you can see a 6th partial sum got me really close. And then I could find out that range of where the sum is, right? I can take that fraction and add it to 0.632. I can take that fraction and subtract it from 0.632. And I now have a range of values that my sum must be in.
Do you really have to add it and subtract it? You just add it and say.
Well, if it asks you for the range, then you would have to do both.
You couldn't just say from like 0.632 to 0.632 plus 1,000 over 5.
Yeah, because if you wanted to know the actual number, you'd have to subtract it to get the value on that side of it.
But then it's never going to get smaller than that point, is it?
Okay, I have not given you 9.5, right? Okay, here you go.
I didn't get 6.
You have it, right? No, I didn't give it. Okay.
Which numbers?
And it is all, the ones that are circled?
Yeah, it is actually, let me tell you, it's every other odd. It's 11 through 35, every other odd. I tried to circle them, but the copies aren't that great. So in other words, do 11, skip 13. Do 15, skip 17. You with me on what every other odd means?
So 35?
To 35, yes, sir. Okay? If you're not going to be here tomorrow or Monday, come see me.
We did a quiz.
Yes, and if you want to see your quiz grade.